Okay, so continuing on with the language of statistics, we looked at what outliers were, we looked at the mean, we looked at the mode, we looked at data, we looked at categorical, we looked at quantitative, qualitative, all of those words. But now we're going to be looking at inferential and descriptive statistics. Okay, so now, inferential statistics. Oops, might just want to write that just a little bit neater. And inferential statistics are essentially generalizations made. So again, we touched on the concept of population and sample. So if we were to have inferential statistics, they would use sample data. So take a survey perhaps, in order to create generalizations about the population. And inferential statistics, well, an example of this could be, say a company surveys what's your favourite type of cereal. Again, that would of course be a categorical statistic because you can't give a number for it, and there's no sort of relationship between Cocoa Pops and cornflakes, which could be numerical. But if we were to look at that, then we could say that if they returned cornflakes as the most popular result from the survey, the sample they took, well, maybe they could say and extrapolate and to say that Cocoa Pops or cornflakes would be the best or most favourite cereal within, or most popular cereal, sorry, within Australia, or whatever their population was. So it's taking that sample data and making generalisations to some extent about the population. Not quite as simple as that. Generally you need quite a lot of mathematics to support that, because of course you can't just say that if you were, hopefully you took a non-biased survey. See the last video if you need to touch up on that. But if you took a non-biased survey and of a decent amount and you kept taking samples and regular surveys out of a very large population, then eventually you will probably see some kind of pattern between different people, generally more so with probably numerical data than categorical, but you can use some maths with probably more numerical side and quantitative data rather than categorical, but you could probably make some generalizations from that by justifying using central limit theorem, which is something that I'll go through in another video. So we have inferential, and then we have descriptive statistics. Okay, so descriptive statistics, they generally look at just what a number set gives you, just what data gives you. So they don't generally extrapolate, they just look at a number. Say they surveyed 200 respondents and they found that the mode out of those 200 respondents was 7, for example. I don't know what the question could have been, but they would say, in a survey of 200 blah blah blah, whatever it was, students, doctors, lawyers, medical professionals, it was found that ... whatever that is, the mode was 7. So they refer to just a particular set of data. They don't generally extrapolate, they don't generally generalize. They just state purely what's there from that data set. And that's the main difference in the wording behind descriptive and inferential statistics. Inferential will probably say 1 in 5 people have a chance of developing osteoporosis. It's an extrapolated statistic, probably taken from lots of different data sets. They probably had a look at people with osteoporosis, surveyed quite a few people, and then they made that generalization. Whereas with descriptive statistics, people would say 1 in 5 people could develop osteoporosis, suggests a survey of 500 people. Generally, you'd just say, out of this many people, such and such had osteoporosis, 1 in 5, whatever, and yeah, that's the main difference. Descriptive states it as is from what the data collected is, and inferential generalizes about the population. Okay, so now that we've passed that phase, we need to move on to looking at the next question. And the next thing that I will briefly touch up on before actually going through a question example is this concept of the standard deviation, denoted by a lowercase sigma. So this symbol actually represents standard deviation, and I won't go into that too much, but generally we have a distribution in statistics, which I'll go through in a later video, and a standard deviation represents a certain amount of the population that fits in there. It gives us an example of the spread of values. So we may have a mean, we may say, okay, 7 people are... should I say, let me think of a good example, something I haven't done yet. In fact, I'll just stick with my television example. Let's say we had 7 people who are, or on average, 7 people found that, in fact, no, let me bring it back to television set. Sorry for fiddling around there, I'm trying to come up with the best possible example. But let's say that out of a survey, it was found that the average number of televisions per household was 5. From that, we could say, okay, well, we know what the average number is, but we don't really know if it's a massive spread. The average, it could possibly be that the average was 5, but then it could possibly be that no one had 4, no one had 3, no one had 2, lots more people had 1, and then some people had, I don't know, maybe 100,000 television sets. Unlikely, but still the case. We need an idea of the spread of data in order to really tell what this actually means in terms of a statistic. And the spread is given by this thing called a standard deviation. I won't go through how to calculate mathematically in this video, but it is something important because it tells us how the data is spread out from a data set. So again, we've been mainly looking at one variable statistics. We will be looking at 2 variable statistics very shortly and moving on because, of course, 2 variable statistics are generally the type that are a bit more complicated, but you can do quite a bit with them as well. And standard deviation will be very important there. Okay, so moving to the last phase now, we have a few questions here. The first question says, statisticians interview people at a nightclub to find their age. So I want to find out what the age of people at a nightclub is, and they record the following values for their age. Say, interview roughly 10 people, and these are the ages of the 10 people that they found. And 24, 26, 28, 52, and 56. Okay, so they interviewed that many people. I think there's about 10 there. Doesn't matter if there isn't. And they said, okay, what are some of the key values behind this? So you've got that numerical data that they've collected. This is, of course, quantitative data, and it's discrete because it's a full integer, their age. And the first question asks, what is the population? Well, in context, this would be people who go to a nightclub. Because, of course, that's where they were interviewing people. And assuming they were just standing at the bar randomly, and they may have asked people who came up what their age was, and hopefully they weren't too offended, but it would probably be a non-biased survey because they just had random people, and they asked what their age was. Okay, and so from that we know our population is nightclubs, people who attend nightclubs, and we know that the sample is taken from this population. And it was probably a non-biased sample. We don't know that based on information given, but we can assume that it was possibly that. Okay, so now we know that there are these values. It asks us what are the outliers. And the outliers would probably be these 2 here, because those ages are significantly different from the others. Okay, and from this, we might be asked to calculate a mean. And the mean, again, is given by x bar equals the sum of all numbers within our data set over the number of numbers. So in this case, the mean would be given by 20 plus 22 plus 24 plus 24 plus 24 plus 26 plus ... you get the idea, and then divide by it the number of people they surveyed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was right when I said 10 before. And if you want to add them all up and divide by 10, you get the average age of someone there. But there is a problem with this, because of course, look, we have significant outliers here, so our mean is going to be pushed up. Maybe, and I don't know, I'm just assuming, maybe our mean might be 27 years. And that's not a really good representation of the population, because, of course, we have lots of 24s, we have a 22, we have another 24, we have a 26 there. A lot of the data, a lot of the people are actually below the age of 27. So it might not be appropriate taking a mean there because of those outliers are going to push the mean up. What we could do is we could probably take a mode. And the mode is probably going to be quite relevant because it shows us the most common age of the people there. And it isn't skewed by our data. So we can see the most common age is 24. We could then look at spreads of data, possibly omitting outliers as necessary. But there's a general look at some of the basic statistical concepts of one variable statistics. And one last question is this categorical or is it quantitative? But I've already sort of covered that. It's quantitative, discrete as well. So think about these data sets, just have a play around with some of these key terms that I've gone across with the language of statistics videos. And if you have any questions, please leave them below. Hopefully you're able to understand everything all okay. If there's any problems, again, question box is there. And it's really important to master the language of statistics. These are just basic terms. You'll learn new ones as you go along. It's just sort of a refresher on some basic ideas in statistics. So thank you very much for watching, and that's all.